Today's note session is about forces. So let's start off with a definition of what a force is. A force is a push or a pull that changes the motion of an object because it gives energy to that object, the energy that it didn't have before. And we'll be talking later in the physics section about energy, but for now let's just say it's a push or a pull that changes the motion of an object. So how do we measure forces? Well, the instrument that we use is a scale, like the scale that you stand on to measure your weight. That's how the force of gravity is acting on your mass. That's what your weight is, so we would use a scale for that, or a spring scale. And the unit for force is the Newton, named after Sir Isaac Newton. And 1 Newton is the force that causes 1 gram of mass to accelerate a rate of 1 meter per second per second. So a Newton can also be called a kilogram meter per second squared, where kilogram is being multiplied times a meter per second squared. And then force is something that has a magnitude and it has a direction, just like velocity did. So we can represent forces by vectors, just like we did for the velocity. So there's various types of force, and the 2 main types of forces that we have are balanced and unbalanced forces. So a balanced force are forces that combine to produce a net force of 0. And when balanced forces are placed on an object, there's no change in the object's motion. So if I am moving at a constant speed in a constant direction, if the forces placed on an object on me are balanced, then I'm going to continue to move at that same speed in that same direction indefinitely. Okay? When you see a change in motion, there has to be an unbalanced force there. So unbalanced forces are forces that result when the net forces acting on an object are not equal to 0. And when unbalanced forces are placed on an object, then the object will accelerate. And we'll talk a little bit about this idea of motion changing because of forces in our next section when we're looking at Newton's laws of motion. So to continue our look at forces, there's other kinds of forces out there that we need to be aware of. There are thousands and thousands of types of forces, but there's a couple that we're going to be considering in this unit on dynamics. So the first one is the force of friction. It's a force that opposes the motion of objects that touch as they pass each other. Okay, so friction, so I have a force that's putting an object into motion, and then I have a force that resists that motion. That force that's resisting the motion is called friction. And there's 4 kinds of friction that we're going to be concerned with. There's static friction. That's the friction force that acts on objects that are not moving. So if you have a heavy box and you try to push it, and it takes a lot to get that box moving at first because it's so heavy, what you're trying to overcome is that box's static friction. It's the force, it's a force that opposes motion for that object and it's not moving, and you have to overcome that static friction to get the box moving. Sliding friction is the frictional force that acts on an object as it slides over a surface. So once I push the very heavy box, I finally overcome that static friction, and then I'm sliding the box across the floor. There is a force that's opposing that motion. You have to keep pushing the box to get it to move because you are working against sliding friction. If I pick that box up and I put it on wheels, like a dolly or something that has wheels, or a wagon or a cart, then I no longer have sliding friction, but I have a rolling friction. As the wheels roll on the surface, then there is a force that opposes that rolling motion. That's rolling friction. And finally, we have fluid friction. Fluid friction acts on an object that's moving through a fluid, and a fluid is either a liquid or a gas. So as you're walking through the atmosphere, you're pretty used to our atmosphere isn't that thick. It's a fluid, but it's not really that thick, and you don't really notice that. There's a fluid friction that you have to overcome to walk through the air. If you are going to walk waist deep in water, you can much better feel that fluid friction that I'm talking about. It's much harder to walk through water up to your hips than it is to walk in our atmosphere up to your hips, right? Because there's more fluid friction there. And you don't even really notice our atmosphere until it's a very windy day, and that wind that's pushing against you, that's part fluid friction that you have to walk against. All right, there are also 4 fundamental forces in the universe, and we've kind of been alluding to these all semester, but I wanted to kind of, now that we're talking about forces, I wanted to bring up in writing what they are. So we've dealt with all three of the 4 fundamental forces up to this point. We had strong force, which we talked about when we were looking at the nucleus of atoms. The strong force is the force that's holding the protons and the neutrons together in the atom. What we didn't talk about is it's also holding quarks. Quarks are the subatomic particles that's making up the subatomic particles. And so strong force is holding quarks together, and then it's also then holding protons and neutrons together in the nucleus. It's it's a force of attraction. Weak force, it's the force responsible for radioactive decay, and it is also starts fusion in stars. And pretty much that's all we're going to say about it, because it's a much more complicated type force. And when you take some college courses, or maybe even some graduate courses in physics, you'll get a better understanding of what weak force is. The other 2 fundamental forces, we talked about electromagnetic force when we looked at ionic bonding. It's a force that occurs between electrically charged particles. We said like repels like 2 protons repel each other, and opposites attract. So a proton and a neutron are attracted to each other. That's what's holding the nucleus to the electrons in the atom. So objects don't need to be in contact to feel the electromagnetic force. Okay, they can be just close to each other, and the magnitude of the electromagnetic force depends on the size of the charge. If you have a lot of negative charge, then you're going to be able to pull that positive charge. Remember how we talked about the effective nuclear force had to do with that, and the distance between the charged particles. And we talked about effective nuclear force with the electrons being further away from the nucleus, how they weren't as tightly held. Okay, so we were pretty familiar with electromagnetic force at this point, and we'll be talking about it more when we look at electricity and magnetism. Gravity is our 4th fundamental force. It's the only fundamental force we haven't really talked about, and it's a force of attraction between 2 masses. It's a force of attraction, so it's pulling objects together. And again, just as with the electromagnetic force, objects don't need to be in contact to be under the influence of gravity. For example, the gravity is what's holding the Earth and the Moon together, and they're not actually touching each other, but they're influencing. The force of gravity is influencing both of those objects. And then the magnitude of the gravity depends on how big the object is, how much mass is there, and the closer that the objects are to each other. So the force of gravity between the Earth and the Moon is very strong, okay, because they have a lot of mass. They're pretty close together. Okay, there is also a force of attraction between our Earth and the Sun. It may not, it may or may not be bigger or smaller than that force of gravity between Earth and the Moon, because the mass of the Sun is much bigger than the mass of the Moon. So you would think the gravity would be bigger, but there is a greater distance between them. And in other physics courses, you will be using something called the law of universal gravitation to describe exactly what the magnitude of gravity is on 2 objects. Okay, well, we're going to use this idea of forces in our next section on Newton's laws of motion, and try to use forces as a means for understanding why objects are moving the way that they are.